Hello everyone. Today we're gonna build the CPK-4 QRPP CWTX kit from crkits.com, and you're gonna receive a pink bag like this. So first step is that let's do the parts inventory based on the part list. Okay, and then this is a PCB, and we have a couple of resistors, three resistors, one diode. In the kit we have three transistors, but we only need two. One is spare, and these are for coils, inductors, and totally 10 pieces of this light green capacitor. 6-pin IC socket, one crystal. This is for 20 meter, and the SMA. This is jumper, and this is short cap. This is a connector for key. Never plug in headphone, otherwise your headphone will be damaged. This is only for key. And this is onboard key, and this is for the battery. This is battery holder. Okay, so it seems to be good. So, and my soldering iron is already prepared. So let's get started to build the kit. First thing first is that we can start with these three parts. Okay, let's start with the diode 1N4148. This is the this black bar is corresponding to this, right? So bend the pin and okay, so plug in, bend it a little bit, or otherwise it will be drop out. And so let's get it sorted. Looks good. And clip it. Clip the extra pin. Okay, so we're done with the first component. All right, we have three resistors. The yellow bar is 47K, and two red bar is 220 ohm, and the other is 10K, with one red bar in the second bar. This is 10K. Okay, so never miss it. So just put in the solder. Alright, before soldering, you can do a double check to make sure that this is 47K, this is 10K, this is 220 ohm, alright? right. We're gonna build step by step. So we can start with the oscillator portion. Oscillator is around the Q1. This is oscillator, and then the amplifier around Q2, and then the LPF, the low pass filter around here. So we can start build the oscillator portion first, and then we can do the capacitors, right? This is 1 2 1 1 2 1 goes to here, and I need a 103 103. This is 103. Yep. 1 2 1 103. Okay, looks quite good. And then we choose one of the transistor to solder in the Q1. Check out the the outline of the component, so never make a mistake here. All right. Yeah, look closer. All right. It looks nice. And then we're starting this is a trimmer capacitor, and so put in the tune C1. This trimmer capacitor is used to fine-tune the transmitter frequency. Okay. Yep. Good. And here, this is 100 microhenry. This is the inductor, fixed inductor, or we also call it RFC or something. It's a very similar name. And this is 100 microhenry. Just put in here. And the crystal, before we install the crystal, we need to install socket. So where's the socket then? You can see that we have 6-pin IC socket. We can rework with your clipper. This is one socket, and this is another. One is used here in the crystal. Uses the crystal socket. I think this is the same as the Pixie 2023. If you have have seen that before, and okay, and it looks cool. And if it's not upright, the vertical to the board, you can adjust it a little bit, but it looks acceptable right now. And the middle pin actually is connected to the ground, so be aware of that. And we need maybe we need to trim the extra pin of the crystal. Maybe leave like a 5 millimeter. Just leave 5 millimeter. It should be good, right? Let's plug in there. Plug in. Right? Yeah. It looks quite good. And yeah, and I still needed to solder the power supply, and also this is a jumper. This jumper, maybe I can use this jumper as a key or something, right? Just put in the pin header, 3-pin header. Just soldered these 3-pin. Okay, and I think pretty much we have done the oscillator portion. I still need to maybe, yeah, I think it's okay. Just let's power up and do some test. And all right, I have 9 volt. 9 volt. This is the this is plus. Plus means that this is the positive, and this is negative. Just to make sure, connect to the center pin. Center pin is the ground of the auxiliary stage. So let's use my Sony SSB receiver. This is very old Sony, and let's see if it oscillates well. Very nice, very nice. The signal is very clear, big and clear, so the oscillator works perfectly. All right. Okay. So let's switch it off and proceed. Just use this shortcut to put on the left side. It's called a key. It means that the oscillator ground will be keyed together with the amplifier stage. All right. Okay, let's proceed to C2. C2 is 47p. 47p. So, this is coupling capacitor. If the value is increased, normally the power output will be increased as well. However, too much power will cause overheat, and also if the capacitor is bigger, it will give the oscillator a lot of load when it's keyed. So it's not good for the stability. So keep the value of 47 P here, and the best value. And let's solder the 22 microhenry. This inductor is the black one. Yeah, black one. Just put it here. Normally, this kind of black inductor is, is bigger size, so it can support bigger current. It's very crucial to support big current in the final amplifier stage. All right, so yeah, I needed to solder another socket for Q2. Sometimes we can replace the Q2 if necessary. For example, if you use a big voltage to damage it or something, overheat or something, you can easily swap it, and there's one spare. And also you can, if you have some good part on hand, you wish to swap it and upgrade it, you still have chance, right? Yeah, looks good. And we need to I think I needed to insert 104, but 104 is just the RF decoupling capacitor. This 104, maybe 3 104s. We can install those 3 104s. This is one part. This is second part. This 104 is the coupling capacitor to the LPF, and this is third. This is the coupling. This third 104 is the decoupling at the power input. All right, and now I think it is possible to test the amplifier stage, but I think we don't have to be worried. Don't have to be to hurry, right? So, okay, now let's install the onboard key. Onboard key. This is not for daily operation, but it's very convenient addition to the board for test purpose or other casual use. So you will like it, I think. All right. Looks perfect. Okay, and this is for the straight key. Plug in here, and you can use a straight key for daily operation. Okay, and yeah, I think the key is ready. So if I solder the power supply, and I can transmit. So, but it's not a good practice to do that, because if you don't connect to the dummy load, the final stage will be damaged because of over uh, current or over voltage. So let's continue to install the LPF portion. For these are band dependent parts. So for 20 meter, 30 meter, 40 meter, they are different. So this is for 20 meters. So the C3 is 220, 2 to 1, all right? And also C4 is the same as the C3, and the C4 is 471, 470p, and we can do that. Bend it. And C5 the 47p, and it will help for to attenuate or as a trap to remove the second harmonic, right? And all right, let's solder these parts. Right, and we still have a few more parts. I think I can solder the SMA antenna connector first. You can start with the center pin, or if you start with the other pins, your finger will be toasted. All right, and yeah, sometimes you need extra time to solder the outer pins because they're connected with the mental body of the SMA. Yeah, a little bit more time will be required, but it looks just fine here. All right, and I think we still have two inductors and the for inductors, and for a 20 meter we need 11 tons. So to save some time, let's see if I can have some stock. All right, if I don't have stock, then I can wind it. And for 11 turns, each turn you can calculate about 1.5 centimeter. So 11 turns, that's about like a 16.5 centimeter, plus some extra, maybe 20 will be good enough, right? 20 will be good enough. Let's start to wind it. You can put it in here and wind it. 2 turns, 3 turns, total 11 turns. 4 turns, 5 turns, 6, 7, 8, 9, 10, 11. This is 11 turns. Let's calculate. 1, 2, 3, 4, 6, 8, 11. Great. And I need another 11 turn inductor. Four, 5, 6, 7, 8, 9, 10, 10 turns. One more 10. Okay, another 11 turn inductor. All right, I need to scratch the outlet something. Let's scratch using some all right. Let me show you how I scratch this part. Put on the surface and scratch with a tiny saw or some other stuff, right? So I can use surface here. Yep, look there. Look at it. Yeah, it's shiny, but if there's still some paint remaining, All right, I think it's good. So let's start with L1 first. L1. And then L2. Okay, L1 and L2. Solder. If the surface is not treated well, if you cannot see shining copper, you probably have some difficulty here in soldering. So make sure that you prepared well. Okay, so I think the final step is to solder the power supply. The black goes to okay. The black goes to here, and the red goes to here. Okay, so trim the extra pins. All right. I think that this is the end of the soldering. Pretty much we are done, and let's prepare the final transistor so I can plug in the socket. All right, let's plug into the socket. Same, check out the outline. Make sure that's properly sorted, or you will have some problem, right? All right. All right, and plug in the crystal. Now it's time to do some test. Clean these extra things. And this is for spare, and we can use tiny SA to do the test. Let's power on it. I can do measure harmonic. It's a 14 megahertz. This is a 40 dB fixed attenuator. All right, let's connect the power supply here. Positive, ground. All right, let's power on. Wonderful. You can hear the sound is the pitch is a little bit high, but it's okay. The output current is about 170 or 160 milliampere. If you can see here, the power output is 26 dBm or like 400 milliwatt, and the harmonic is minus 55. Only the second harmonic minus 55 or 56. So it's perfect. It works perfect. And so it's so great, right? So let's adjust the tremor capacitor to see if it can change the frequency. Perfect. It works as expected. It's a little bit trippy, yes, because the oscillator is keyed as well. If you want to change the setting of the oscillator ground to permanent ground, you can hear that it's oscillating, and the output is about 8 dBm. Still a little bit strong, right? 8 dBm if you don't key it, and if you key it, it will reach like 400 milliwatt or something. So if you have all right, so if you have a receiver nearby, you probably will consider to switch to the key side, or otherwise the oscillator is operating all the time and you will hear a strong local frequency, right? Okay, pretty much this is it, and thanks for watching. Hope you enjoy the kit building.